Have you ever seen an AI describe an image or answer a question about a picture? That's not magic. That's the power of visual language models. Hi everyone, welcome back to Danesh Academy. It's Amin Hajjari again, AI researcher and data scientist. Today we are going to explore how machines are learning to see and talk at the same time. In this video, we will explore vision language models step by step. First, we'll define what vision language models are and why they are important. Next, we will look at how they work under the hood. Then, we'll explore some of their most exciting applications in the real world. We will also discuss the challenges and the limitations these models face. After that, we'll look ahead at the future trends in this fast-moving field. And finally, we'll wrap things up with a quick summary. Vision language models, or VLMs, are a new type of AI model that can understand both images and text. And instead of just reading or just seeing, they do both. This allows them to generate captions for images, answer questions about pictures, and even hold conversations about what they see. So, how do they actually work? Imagine feeding an AI a picture and a question, like, what is the person doing in this photo? The model processes both the image and the text together, using spatial architecture, usually a combination of a vision encoder, like a CNN or a vision transformer, and a text encoder, like a language transformer. Some models use what's called a two-tower system, one side for image, one for text, and they bring them together in a shared space. Others use a unified transformer to handle both modalities in a one go. Where do we actually use VLMs? They power tools for image captioning using accessibility apps, visual question answering for education or medical tools, multimodal search like searching images with words, and even robotic systems that need to understand their environment. But it's not all perfect. VLMs still face challenges. They can hallucinate, making up wrong answers. They may inherit biases from their training data, and they struggle with grounding, linking text to real objects. But with advances in grounding, fine-tuning, and better datasets, VLMs are improving fast. Looking ahead, vision language models are evolving rapidly. One key trend is better grounding, where models don't just describe images, but truly understand objects, relationships, and context within them. Another direction is multimodal integration, combining not just vision and text, but also audio, video, and even 3D data to create richer understanding of the world. We will also see improvements in efficiency, making these models smaller, faster, and more accessible for everyday applications. Finally, there is a big push toward trustworthy AI, reducing hallucinations, removing biases, and aligning VLMs with human values. Altogether, the future of VLMs is moving toward models that are more accurate, more reliable, and more capable of interacting with the real world. So, that's a quick look at the vision language models, the AI that sees and speaks. If you found this interesting, don't forget to like, subscribe, and hit the bell icon for more AI deep dives. See you next time. Before we go, here's a quick demo. Watch how a vision language model narrates what's happening while someone draws on a paper. It's pretty cool.
Describe what you see in a simple way.
The picture shows a white piece of paper with some text on it. There's also an oval-shaped mark in the middle, colored blue and filled.
What do you see?
The image shows a piece of paper with what seems to be an outline or drawing on it. The outlines appear to depict the basic form and features of a rabbit, including prominent ears that are upright as well as suggesting some sort of body shape below them. Due to viewing angle limitations and potential for perspective distortion, such
What animal is this?
the image depicts a simple line drawing of an animal. Specifically, he resembles that of a rabbit. You can tell this due to the following characteristics evident in the sketch. The shape and positioning of ears. There are two long lines extending from what might be considered earlobes upward on both sides of its head. The outline form of the face. Head area is circular with short strokes connecting endwise or diagonally for each whisker veneers over time.